All right, so 2D motion. So the big ideas are gravity only acts in the y direction. There's no acceleration in the x direction. X and y act independently, so the monkey shooting goes over that. Time going sideways is the same as the time going up and down. And for problem solving, we do the same thing by writing givens, but now we're going to do stuff in the x and y direction. First step is always figure out what Vx and Vy are. We're going to need to find components of those. Identify what you know in the x and y direction. Labeled sketches are a good thing. Find time in whatever direction gives you enough information to do that, and then find whatever else you need to do. So, in the x direction, there is no acceleration. A is 0. So in this equation, that goes away, and we have V is equal to V0x, which is completely not helpful. In the x direction, or in this equation, we can make those two things be 0. That's going to give us x is equal to Vxt. That is very useful. And then here, that goes to be 0. So we have Vx squared is equal to Vx0 squared, which is completely not useful. So the useful equation in the x direction is that one. In the y direction, the acceleration is the acceleration due to gravity, so g. So we have Vy is equal to V0y plus g times t. We have y is equal to y0, although that's usually just going to be 0, but not always. And then plus 1/2 at squared, which will be gt squared. And then Vy squared is equal to Vy0 squared plus 2gy. All right, so let's go through some example problems. We have a soccer ball that's kicked horizontally off a cliff. The cliff is 100 meters tall, and the ball is going 20 meters per second. It's going to follow a path something like this. We want to know how far from the base of the cliff it's going to land. So in the x direction, we have Vx. Since that's horizontal, that's going to be 20 meters per second. And that's all we've got. In the y direction, we know the height of the cliff is 100 meters. But we also know that the initial speed in the y direction is 0. And we also know that the acceleration in the y direction is g, so 9.8 meters per second squared. In order to figure out what this distance is, what x is, we have x is equal to Vxt. So looking at this equation here where we've taken all that stuff out, we're going to need to know t. We don't have enough information in the x direction to do that, but we do in the y direction. In the y direction, we have y is equal to y0 plus v0t plus 1/2 at squared. This goes away, this goes away, and we can solve this for t. That's equal to the square root of 2y over a. And that's equal to the square root of 2 times 100 over 9.8, which is equal to 4.52 seconds. So then we can go back and solve for x. This is 20 times 4.52 seconds, and that will be equal to 90.4. And so it's just that going back and forth to solve that problem. So now let's look at the v and a graphs in both the x and the y direction. So in the x direction, v is constant. So it's always going to be whatever speed it was when it started. So that's going to be 20 meters per second. And there is no acceleration, so that's just going to be right on the 0 line. So our x graphs, that's what they're going to look like. In the y direction, our speed started at 0, and it's going to speed up as it falls. and our acceleration is going to be constant at 9.8 meters per second squared. So now let's take a look at problems where they go up and then down. Here, our Vx was 20 meters a second. Our Vy was 0 to start with, so we didn't have to find components. They just were all or nothing. So let's review just up and down motion. So a volleyball is thrown straight upward at 20 meters per second, so V0 is equal to 20. And it seems like that is our only given, but it's not. We know that the speed at the top is 0, that acceleration is negative 9.8 meters per second squared. And that's negative because we've defined up to be positive by making our speed be a positive 20. It's going to slow down as it goes up, which means we have a negative 9.8. So we can use V is equal to V0 plus AT. Solve that for the time up. V minus V0 over A. That's going to be 0 at the top. So that's our time up. So that's our speed that we want to end with. 20 is what we're starting with. That's going to be negative 9.8. And we're going to end up with this time of 2.04 seconds. To find the time in the air, because it's landing at the same height that it's going up, or it's landing at the same height that it started, that's 2t up is equal to the time in the air. It's going to be equal to 4.08 seconds. To figure out the height that it reaches, we can use a couple of different equations. We can use y is equal to y0 plus 1 v0t plus 1/2 at squared. So this would be going away. Our initial speed is 20. The time that we want to use is our time up, because that's the time that it takes to get to its highest place. If we use the time in the air, we would get 0 for our height because we'd be back down at the ground. Our acceleration is negative, and that's going to give us a height of 20 meters. We could also use v squared is equal to v0 squared plus 2ay and solve for y. Which would be 0 minus 20 squared over 2 times negative 9.8, which gives us the same thing. Watch order of operations. Make sure you put this part in parentheses so you're dividing by the whole bottom part. Then our Vy, we start at a positive 20. When it gets to the top, it's going to be 0, and when it comes back down, it's going to be negative 20. And we know that our acceleration is constant, so it has to be a straight line, so our slope stays the same the whole way. Our acceleration is a negative 9.8 no matter where we are. And this will be 20. All right, so now let's take a look at a football that's kicked upward 20 meters per second, but now it's 30 degrees above the horizon. So we have a speed going 20 meters per second. It's 30 degrees. Step 1 is to find Vx and Vy. And we're going to need to do components of that. Vx is going to be V cosine of theta. And Vy is going to be V of sine theta times sine theta. This is equal to 20 times the cosine of 30, which will give us 17 meters per second. This will be 20 times the sine of 30, which will give us 10 meters per second. So that's the first step. That's the most important part. If you don't do this, you can't do any other part of the problem. In the x direction, we've got Vx is equal to 17, and that's all we've got. In the y direction, we have an up and down problem. We know that we're headed up with a speed of 10 meters per second, that v is equal to 0, a is equal to negative 9.8. And we're going to do the exact same thing that we did here, but instead of using 20, we're using 10. We're using the speed that it goes up with. So our time up is going to be equal to v minus v0 over a, which is 0 minus 10 over negative 9.8, which is going to be equal to 1.02 seconds. Our t air is twice that. So 2.04 seconds. We can find our height. This will be 10 times our time up. Again, we want the time up because that's the time that it takes to get to the top. It's 1/2 negative 9.8, and then 1.02 squared, and that would be equal to 5.1 meters. Or we could use this equation, and that would also work. This would still be 10. And then last step was to figure out x. X was equal to vxt, which is going to be 17, and again, we want the time in the air. The time to go up will get us this far. We want the entire x distance, so we want the time up and back down. So this is going to be 2.04 seconds, and that gives us 35 meters. So for this problem, we go straight up. It spends a really long time in the air. We lose a lot of that time in the air because not all of that is going up in this problem. Half of it's going up and half of it's going sideways roughly. So we lose time in the air, which means we also lose height. So our height doesn't get anywhere near as high. This was 20 meters. This is only 5 meters that it goes up. But this one doesn't go sideways at all. And here we're going 35 meters sideways. So we gain a lot horizontally, but we lose a lot vertically by shooting it at an angle. A couple of things that I want to call your attention to before we do the graph. We've got Vx, which is 17, and that's what goes here. And that's what we use here. We've got Vy, and that's what gets used here, and here, and here. And we don't want to use that 20 meters a second anywhere. This is T air. For the whole distance. And for these, we want to use T up, since that's where it's the highest. Okay, so now let's take a look at those graphs. In the x direction, Vx is constant. In the x direction, V does not change, and that was 17 meters a second. There is no acceleration in the x direction. And in the y direction, we're going to start at 10 meters a second. We're going to go down to 0 when it gets to the top, and then it's going to be a negative 10 So it's going to look just like this one. And our acceleration is going to be negative 9.8 the whole time.